Assalamu alaikum dear students. Today we are going to solve few questions from this paper, May June 2004, and these questions will be actually from chapter number 1 to chapter number 4, which we have already discussed in our theory lectures. So this is the paper 1, of course, 9702 MCQ paper 1R. But here, of course, we are not solving all the questions, only the related questions which actually we have discussed in your theory classes. So which pair contains number 1, which pair contains one vector and one scalar quantity? So this is a simple question, because here you need not to go into any details or any understanding. Here simple thing is that if you have the concept that which quantities are scalars and which are vectors, so simply you can give the answer. Here one vector and one scalar quantity. So displacement, is a vector quantity. Acceleration is also a vector quantity. So this will not be the option. The next part is here force and kinetic energy. So you know that force is a vector quantity and kinetic energy or any type of energy is a scalar quantity. So simply you can say that this is our answer in this case, but we can check the other options as well, like momentum and velocity. Momentum is a vector, and also the velocity. So this is again not a correct answer, of course. And as far as the last part or option is concerned, here you have power and speed, and both of these are scalar quantities. So with the help of these type of questions, you can recall the examples of scalar and vectors as well. So as I said that both of these, option D, quantities are scalar quantities, so this will not be our answer. So simple thing is that B is the answer in this case. Which of the following could be measured in the same unit as force? So first of all, we have to recall what is the unit of force. So you know that F is equal to ma. So as far as the unit of mass is concerned, it is kg, and acceleration is meter per second square. So simply you can say the Newton or kg meter per second square is the unit of force. So here we have to check that which option is giving us the same unit. Over here, the first option you have is energy. So you will check that what is the situation of the energy. The unit of energy is the joule, and unit of distance is meter. As far as the joule is concerned, this is basically work done, and work done is nothing but your Newton meter, because work done is nothing but force into displacement. So when you will use the unit of force is Newton, and you will use unit of displacement, this will be meter. So this is Newton meter, and of course distance is measured in meter. So simply you can say that this is nothing but Newton. So simple, first option is your the correct option, you can say, because this is something which is giving us the same unit as a force, which is nothing but Newton. Remember this thing, that if you will write Newton, always start from a small letter. Okay, so here you have this option. The rest, of course, you can check. Over here you have energy and distance. So this is nothing but joule meter. So this will not be possible. Energy divided by time. Energy divided by time is basically the power, you can say. So this is joule per second, which is again not the required thing. So these are not options, correct options. Here you have momentum. You know that momentum is nothing but your mass into velocity, and when you will go for their units, you will see that here you have kg meter per kg, here you have kg meter per second as far as the momentum is concerned, and then you have the distance as well. So when you will multiply it by distance, the unit will come as kg per second or kg meter square per second. So this is of course not the Newton, so this is not the option. So this is what we have. The first option is the correct one. So we can go directly, but just to tell you that what is the you can say units of other options. I just have solved these one as well. Question 3. The notation mu s is used as an abbreviation for certain unit of time. Mu is basically for micro. So what is the name and value of this unit? So simply you can say that micro. So milli, of course, milliseconds. These two options you can reject outrightly. As far as the microseconds are concerned, both these options, any A and B, seems correct. But when you will go for the value, 10 to the power minus 3 is not micro. This is milli. So remember this thing that this option is not correct as well. Yani B is not correct as well. So simply you can say the correct option is only A. So remember these things, that what and how we can determine the units of different values, you can say, and multiple of these values. Then in question 4, what is the reading shown on this milliammeter? So remember this thing, that this question is easy because here you have directly milliammeter is given, only you have to check readings. You can see here that between 2 and 0 you have certain values, and if you will mark these values, you can say that this is suppose here you have 0.4, this is 0.8, this will be 1.2, this will be 1.6. So it means that here we have a gap of 0.4 for each digit. For each digit we have the gap of 0.4. So here you have the value 2.4, here you have value 2.8, here you have a value something 3.2, and in between somewhere here. So above 3.2 and 3.6, so simply you can say the reading will be nothing but 3.4 millisecond. So as we are just getting the value, so of course all other values we can reject, and this will be our answer, simply 3.4. Go it again. Here you have 2, so this is 2.2, this is 2.6, this will be 3.2, and as you are in between 3.2 and 3.6, so that's why we are getting this value 3.4. This is your 3.2, and here you have 3.6. So in between these two you have your needle, so the value is nothing but 3.4. So remember this point, that how you have to get this value. Then actually we have not discussed this part, oscilloscope, as in detail, but it's simple because you have studied this in IGCSE and O level as well. The following trace is seen on a screen of a cathode ray oscilloscope, CRO oscilloscope, and you know that along x-axis you have here the time, and ultimately you can get the value of frequency. The setting of the time base is basically a sort of scale, and with this scale we have to determine that what is the time period, because here you have a complete wave from say A, B, C. So from A to C you have a complete wave. So this is something which we have to determine, that what is the value here and what is the question they are asking. The setting of the time base is then changed from 10 millisecond per centimeter. Yani initially this centimeter thing is nothing but 10 millisecond. So 10 millisecond and so on. So how many centimeters you have? 4 centimeters you have for one wave. 1, 2, 3, 4. Yani to complete a time period you have these 4 centimeters, which will give you nothing but 40 millisecond. 40 millisecond. And what they are saying that you have changed the setting from 10 millisecond to 20 millisecond. 20 millisecond per centimeter. So what will happen now? So if you have 20 millisecond per centimeter, then what will be the situation of this 40 milliseconds? So simply you can say that this 40 millisecond will be nothing but, you can say, covered 2 centimeters. Yani what will happen? Instead of this wave, you will have a shorter wave. And which one is the shorter wave? Which trace is now seen on the screen? So you know that here the 4 boxes you have, only the change of amplitude is here. So this is not right. Here you have increase, instead of decreasing you have increased to 4, yani instead of 2 or 4 boxes, here you have 8 boxes for a complete wave. So you can say that the time period has increased. So this is not also the correct option. Similarly, D, again you can say and see that both amplitude and the time is different. So this is absolutely wrong. Only C will be the correct option, where the amplitude remains the same as our trace. Here we have 2 centimeters. Here we have 2 centimeters as far as the amplitude is concerned, but the point is the time has decreased to only 2 centimeters because the setting is of 20 millisecond. So I hope you have understood what I have discussed here. The decrease in setting will increase the you can say shape of the wave, and increase in setting will decrease the shape of the wave. So we have decreased the shape of the wave. Simple thing is that C is the answer. Then we have question 6. In a simple circuit, electrical circuit, the current in a resistor is measured as this much millisecond. The resistor is marked as having value of 7.4 ohm plus minus 2%. Be careful here. The percentage uncertainty of resistance is already given, which is 2%. In this case, percentage uncertainty of the current in the resistor you have to find, which will be nothing but 0.05 divided by 2.50 into 100. Of course, you can calculate this thing and you can find the value. But what is the question? If these values were used to calculate the power dissipated in the resistor, what would be the percentage uncertainty in the above in the value obtained? So remember, first of all, that power in terms of current and resistor is given as P is equal to I square R. And when you will go for the percentage uncertainty, so simply you can say the percentage uncertainty of power will be equal to 2 times of percentage uncertainty of current. Again, you have to go to my first lecture where we have discussed the uncertainty thing, first or second lecture, the chapter number 1. And of course, here you have the percentage uncertainty R. So to get the detail of this concept, you have to go to the theoretical part. And here we have this thing that 0.05 you can even calculate over there, and 2.50 into 100 plus 2%, and what you are getting is nothing but 6. When you will calculate this thing, you will get 6%. So simply you can say that the answer is nothing but C. And as we have calculated our values, so of course the rest of the calculations or the results are incorrect. So option C is the correct option, and that's it. So this is what we have to do here. Then in question 7, a car is traveling with a uniform acceleration along a straight road. This is the basic concept, uniform acceleration. And actually in theory we have discussed that for uniform acceleration we have these formulae. S is U, V is equal to U plus AT, S is equal to UT plus half AT square, and 2AS is equal to V square minus U square, where all these you can say symbols are representing their own quantities, like final velocity, initial velocity, distance covered, acceleration. And remember this thing that again I'm using the same word, that these all set of equations for uniform acceleration. So be careful. The road has marker post every 100 meter. Yani what we have here, one mark, another mark, and the distance between these two is 100 meter. When the car passes one post, it has a speed of 10 meter per second. So it means that when you are somewhere here at post 1, you have the speed 10 meter per second. And when it passes the next one, its speed is 20 meter per second. So for the second post, you have 20 meter per second. So what we have here, what is the acceleration, car's acceleration? So simple thing is that if you will check these equations, like suppose the first one, you have the final velocity, you have the initial velocity, acceleration is required, but t is not here. In this case, the t is not here, v which is given is not being used of course in this equation, so this will not be the required equation. So simply we can say that the third equation of motion, which is 2as is equal to v square minus u square, will give us the you can say answer for this question. So 2 into a into 100, v is nothing but 20 square, and u is nothing but 10 square. When you will calculate this thing, 400, 100, and here you have 300. So simply you can say that here you have 200a. So a is 300 divided by 200, and simply you are getting nothing but 1.5. So answer of this question will be 1.5, simple. So again the same thing, as we have calculated the value and correctly calculated the value, so the rest of the options will be of course not correct. So this is what we have. I hope you have understood this question. Then in question 8, a tennis ball is released from rest at the top of a tall building. A tall building you have, and you are dropping a tennis ball. Which graph best represents the variation with time t of the acceleration a of the ball as it falls, assuming that the effects of air resistance are appreciable? Yani the effect of air resistance is here. So you know that of course the value of a will not remain the same, because the air is acting on the body or giving a sort of resistance. Then of course it will not increase with time. Then what we have, excuse me, the acceleration is increasing with decreasing rate. So though no concept of the increase of acceleration. Simple thing is that as the of course the body is going down, you have one force is weight, the other force which is acting is the frictional force, which is because of air. So what will happen, you know that when W becomes equal to your frictional force, then the body will be in equilibrium and there will be no net force acting on the body. So simply you can say that the acceleration is slowly and gradually decreasing with time. Not of course all these above A, B, C. So simple thing is that C is not, B is not, A is not, but only D will be our option, where acceleration decreases with time. And at one stage of course it will be 0 when the weight will become equal to F. But over here of course this part is not showing this situation, but this actually at least showing you, the graph is at least showing you that there is a decrease in acceleration in the presence of air. So the air resistance is working, and simply that's why you are considering your option D as a correct option. Now question number 9. A motorcycle stunt driver moving horizontally takes off from a point 1.5 meter above the ground, landing 10 meter away as shown. So you can say this is a sort of question which we have for projectile motion or from projectile motion. The vertical distance is given, the vertical distance is given, the horizontal distance or the range is given, and what was the speed at takeoff, what was the speed here. This is required. So you have to again recall this concept, and you have to go to my lecture for the projectile motion. And if you are new on this channel, so subscribe this channel, press the bell icon, and of course share and like if you are understanding this whole discussion, so other students can also get the benefit of this channel and this discussion. So the theory basically says that when the motorcycle cyclist will start, you can say this stunt, so simply the velocity will be the horizontal velocity, and over here the vertical velocity will be zero. Over here the vertical velocity will be zero, but the time we can calculate with the help of h is equal to ut plus half at square, or simply you can say that minus gt square. And what is the height? 1.25. What is the initial vertical velocity? 0. So this becomes 0, and over here minus. So you can say that if you are using minus or plus, doesn't make any difference. So basically what you are doing here, you are taking downward distance as positive. That's why you are using this positive sign, half into 9.8, and here you have t square. So with the help of this, actually you are calculating the time, and you have to remember this thing, that the time for your vertical distance covered and time for horizontal distance covered is always same in case of projectile motion. And again I am saying that if you want to understand this whole discussion, go to the projectile motion, to the lecture I have on the projectile motion. And of course the chapter will be the chapter number 2, and you can see that how we are explaining this whole thing. Over here simple point is that 1.25 divided by 9.8 whole is square root. When you will take, you will get the value as 0.50. And as I said that this time will be not only the vertical displacement but also for horizontal distance. So simple thing is that we can use now the simple formula, s is equal to ut, or over here we can say that s is equal to uh into t. So what is required? Is required. So s is given as 10, and over here you have time as 0.50. So ultimately you will get nothing but 20. So again, it's a simple calculation, and two steps calculation you have. In the first step, you are calculating the time, and as I said that time for both the vertical and horizontal distance is the same. So here what you have, and of course the answer is nothing but D. And the other of course options, as I said that you have already calculated the value, and if you are logical, then of course you need not to go for other options. So this is what we have. Again I am saying that if you want to understand the projectile motion, because this question is based on projectile motion, so go to my lecture on the projectile motion, and then you will be in a better position. And if you have already gone through the projectile motion, then this question will not be a difficult part for you. Question number 10 of this paper. A ball falls vertically and bounces on the ground. The following statements are about the forces acting while the ball is in contact with the ground. With ball is in contact with the ground. So this is very important. Forces we want to know, and when the ball is in contact with the ground is the condition. Which statement is correct? The force that the ball exerts on the ground is always equal to the weight of the ball. No such concept we have. The force that the ball exerts on the ground is always equal in magnitude and opposite in direction to the force the ground exerts on the ball. You know that this statement is basically nothing but the Newton's third law of motion, where you have two bodies applying forces on each other, and one force is the action, so other is reaction. So the ball will exert a force as the earth is also applying a force on the ball. So simple thing is that you can say this is the statement of the Newton's third law of motion, and this will be our answer. The rest is of course not right options. The force that the ball exerts on the ground is always less than the weight of the ball, so weight is doing nothing here. As such, the weight of the ball is always equal in magnitude and opposite in direction to the force that the ground exerts on the ball. Again, the same thing is not important as such. The weight of the ball is always equal in magnitude and opposite in direction to the force that the ground exerts on the ball. Basically, if you can recall, the force that the ground exerts on the ball is nothing but weight of the ball. So be careful that this statement is wrong because of this reason, that the force which the earth will apply on the ball will be equal to the weight. This is not in opposite direction. So be careful of this misconception. So the simple answer is nothing but B in this case. Question number 10, answer is B. Okay, then you have the situation over here that question number 11 you have, and in this question what they are asking, the momentum we have in this case, and what is the question? Simple. Here you have the diagram shows the situation just before a head-on collision. Head-on collision. Remember this thing that whenever you will have a head-on collision, the collision is elastic collision, but for the time being we need not to go into that detail. What is the question? A lorry of mass 20,000 kg is traveling at 20 meter per second towards a car of mass 900 kg traveling at 30 meter per second towards the lorry. So here you can say that this is the positive direction. So this momentum you can say is M1, momentum of the lorry, and here you have the opposite direction. Momentum in the opposite direction is momentum of the car. So what they are asking, what is the magnitude of total momentum? So remember this point, that whenever you will talk about the total momentum, you have to recall one thing, that momentum is a vector quantity. And again the same thing, if you are new on this channel, then you have to go to my lecture on momentum, and in that lecture we have discussed in detail that what is the situation of the momentum and how we have to deal with these questions. So simple thing is that you have two vectors in opposite direction, so the total momentum suppose is m, and you will get it by subtracting these two momentums. So what is the first momentum? Mass of the lorry multiplied by the velocity minus mass of the car multiplied by the velocity of the car. So simple thing is that you are getting a value which is 373,000 Newton, or you can say that this is nothing but 373 kilo Newton second, not only Newton second. So kilo Newton second, this is what we have as far as the answer of this question is concerned. So simple thing is that the calculation says that answer is nothing but A. The rest of the options will be of course not right. If you will apply the same or correct concept, you will get the correct answer automatically. Then here we have another question which is based on, I think, density and upthrust, which we have studied in forces. An object immersed in a liquid in a tank experiences an upthrust. So this is the basic concept of upthrust. What is the physical reason for this upthrust? So again the same thing, I have discussed this upthrust in detail in my lecture based on upthrust. So you can go through that lecture as well for the theory, but as far as the upthrust is concerned, we have to check that what is the situation here. What is the physical reason for this upthrust? So density of the body differs from that of the liquid. No concept like this. The density of liquid increases with depth. Absolutely wrong. There is no concept of change of density with depth. and the pressure in the liquid increases with depth. So remember this thing that we have basically the upthrust is nothing but the upward force, which is the result of the difference of two pressures on two, like suppose if you have this situation, so you will have one pressure here, you will have another pressure here. The difference of these two pressures multiply by area of this particular thing of object. So this will be basically the upthrust. So basically, of course, area will remain the same, but basically the upthrust will give you the you can say the on your object, because of the pressure in the liquid increases with depth. So this is the basic concept, and this will be our correct option. The value of G in the liquid increases with depth. We don't have any such concept, so this is also wrong. So be careful that the upthrust is nothing but the force which is because of the difference in pressures at two different depths. Of course, the area, actually you have to recall this formula as well, that force is equal to pressure time area. Pressure time area. So in this case, pressure is different above and below of the object of the area A. So basically you can say the upthrust is caused because of this change in the pressure with the increase in depth or with depth. So this is what we have as far as the explanation of this question. I hope you have understood this thing. Then we have another question based on forces. A uniform beam. I have explained again this whole concept of uniform beam in my theory lecture. So if you want to go to theory, go to the theory lecture on the forces, chapter number 4. A uniform beam of weight 50 Newton is 3 meter long and is supported on a pivot situated at 1 meter from one end. So this is the pivot you have here. But remember one thing, that 50 Newton is the weight of the beam, and as you have the uniform beam, always you will have the force which will act at the center of the body, or the geometrical center of the body, if the body is uniform in structure. So if the beam is uniform, the weight of the beam will act at the center of the rod. Be careful. When a load of weight W is hung from that end, the beam is in equilibrium as shown in diagram. What is the value of W? So I think it's very simple. You have to only recall the principle of moment, which says that the anti-clockwise torque in this case is because of this W. Here you have anti-clockwise torque, and this is giving you the clockwise rotation, but of course the weight of the rod is giving you this rotation. So you can draw like this. So W into 10, or rather 1, not 10, and of course here you have WB, which is with the distance of 0.5, because here you have a complete length of 3 meter, but as you know, the middle point or midpoint of the rod is the point where the weight is acting, which is at a distance of only 0.5 from the pivot. So 0.5 will be the perpendicular distance from the pivot. You need not to consider this one or this one, only the distance from the pivot. So simple thing is that the weight is given 50, and of course you can get the value of W, which is nothing but 25 Newton. So it's very simple. Again, calculation says that the answer is 25, and if you are confident enough, you need not to consider any other option. You have calculated this value with the correct equation, so answer will come automatically, and you can say the correct answer you will get automatically. You need not to worry about other answers. Now question 14, the diagram shows a sine of weight 20 Newton. Here you have the sine of weight 20 Newton. Suspended from a pole attached to a wall. Here you have the attachment. The pole is kept in equilibrium by the wire attached at the point X. So with this point you have a wire attached which is supported with you can say the wall again at X of the pole. The force exerted by the pole at point X is F. So what is happening? The force exerted by the pole at X, the force exerted by the pole at point X is F. So here you have this force F, and the tension in the wire is 40 Newton. So this is the force which is termed as tension, and this is 40 Newton. Which diagram represents the three forces acting at the point X? So be careful. Actually, you need not to worry about these type of questions. Only check which triangle is a closed triangle. Again, if you want to go to details, you have to go to the lecture, theory lecture based on the forces. But I am just telling you one simple thing, that whenever you need to get the idea that you have the equilibrium, at equilibrium or in equilibrium, so the triangle which you you can say having here must be closed triangle. So check which triangle is the closed triangle right here. So if you will suppose consider this one, here you cannot go, this will be your resultant force. So this is not the correct answer. This is not the correct answer. Here you can check 20 Newton, F force which is of the pole, and here you have force tension. So all these forces are giving you a complete closed triangle. So it means that there is no unbalanced force acting in case of B, and this is something which is giving us the idea that this is the situation of the equilibrium. We can check the other triangles as well. Like suppose here you have a situation F, here you have, then you have 20 Newton, which is downward is okay, but it's not giving you the closed triangle because this part is in such a direction that this is giving you the resultant force. So of course this will not be a correct option. So you can use this color, as we have been using this color, doesn't make any difference as such. But again the same thing for D, what you are getting, here you have one force, here you have another force, and this force is the resultant force. So in these cases you have the resultant forces, so all these will not be the situation of the equilibrium. So remember this thing, that we have the situation of the equilibrium. As far as the triangle is concerned, it should be a closed triangle of forces. And as I said, that if you want to go into details of this you can say question, theory of this question, then you have to go to my lecture which I have on the YouTube. And this is I think of course chapter on forces, and I think second chapter, I think you will have the second lecture you will have. So I hope you have understood these questions. So inshallah in the next class I will upload the questions of your October, November. Here you have May, June 2004. So this is what you have. As I said earlier, that if you are new on the channel, so subscribe this channel and press the bell icon so you can get the new uploaded videos as soon as I will upload. And of course, if you like this, so press the like as well and share with your friends so other students also can get the benefit of it.